Zihniyyətə gələrlər yəqin ki, görüşün davamında. Deməli, biz bu gün AEN Paper Club-ın ikinci mitinqini təşkil edirik. İlk mitinqdə göstərdiyiniz dəstəyə görə çox sağ olun. Həqiqətən də bir 20-yə yaxın adam iştirak eləmişdi mitinqdə. Deməli, bu gün də bizim spikerimiz Yusif Əliyevdir. Biz bu gün onun çıxışına qulaq asacağıq. Çox da vaxt itirməyək, ona söz verək, başlayaq mitinqimizə.
İlk öncə hamınızı salamlayıram. Qoşulduğunuz üçün çox sağ olun və məni qonaq etdikləri üçün Paper Club-a və AEN-ə təşəkkürümü bildirirəm. Bugün sizə automation və AI haqqında danışacağım. İstəyirsinizsə başlayaq. Deməli, slayd və danışıq ingilis dilində olacaq. Əgər hər hansısa bir sualınız olarsa, istər slaydın ortasında, istər slayd bitdikdən sonra suallarınızı bildirə bilərsiniz. Good to see you, everyone. Thanks for having me. My name is Yusif Əliyev. I'm going to walk through a topic from human-computer interaction called automation, specifically how AI systems take over parts of the task we used to do ourselves, and what that means for how we design and interact with technology. This should take about 15 to 30 minutes. I will cover how automation actually works, how tasks get split between humans and machines, a couple of frameworks researchers use to design good automation, and I will close with some real risks, including a well-known aviation disaster that shows what happens when this goes wrong. Feel free to hold questions until the end or jump in if something's unclear. Happy to pause. Let's get into it. Interactive AI. So, automation and interactive AI. Today, I'm covering chapter 20 from our HCI reading on automation. Automation just means a system doing part of task that a human used to do. That sounds narrow, but it actually is everywhere. Autocomplete, spell check, insurance pricing algorithms, movie recommenders, self-driving features in cars. In the next 15 minutes, I will walk through what automation and agents actually are, how tasks get split between human and machine. The frameworks HCI researchers use to design good automation, and finally, the ironies that make this such a hard design, including a real disaster case. Automation is already everywhere. Let's ground this with our explaining examples. On your phone, keyboard, language models, propose completions and fix typos as you type. Insurance companies use AI models to calculate your fee based on health and other data. Semi-autonomous vehicles can drive parts of a road on their own, but they need to hand control back to you in situations they can't handle. And recommender engineers aren't just for movies and music anymore. They can suggest slide layouts to someone building a presentation or poster designs to graphic designer. The common thread. In every case, the AI takes over part of the task, not all of it. What is an agent? When a system has this kind of agency, the ability to do things on its own, we call it an agent. You will see it called a software agent, an intelligent agent, or a personal digital assistant. They are all the same idea. Agents interact with us in two basic modes. Some are reactive. They only respond when you give input, similar to a regular command line or graphical interface. Others are proactive. They continuously monitor what you are doing and act on your behalf. Without being asked, that's the distinction: reactive versus proactive. Direct manipulation versus software. Agents, software agents. This tension goes back to a famous 1997 debate between two researchers, Mas and Snyderman. Maths are good for software agents. They learn your habits and preferences. They're like proactive, like an extra pair of eyes or ears, and they are long-lived, meaning they persist and improve across sessions. Snyderman pushed back for direct manipulation. He said users need to predict what will happen, explore freely, and feel in charge, and that we shouldn't confuse human responsibility with machine output. Interestingly, they ended up agreeing on something in between mixture. Uh, Initiative interfaces where users can directly manipulate the agent itself, task sharing, two approaches. So how the humans and machines actually divide up work. There are two ways to share tasks. The first is time sharing. The user does manipulate the task at once. This only works smoothly for the tasks that are automatic, like talking while walking. Try to time share two tasks that both need your full attention and performance. The second is control sharing, where control over part of the task gets handed to another agent, and that agent could be another person or it could be a machine. Most automation design is really about the second kind. How much control to hand over and how. Extension relief and partitioning. Control sharing itself breaks into three mechanisms. Extension is when the machine amplifies your ability. Power steering in a car or mouse acceleration on a screen is the classic example. Relief is when the machine reduces your overall burden. Automatic transmission means uh, you don't have to shift gears. Autocomplete means less typing. Partitioning is when the task is split into parts, one for the human and one for the machine, like semi-automatic parking, where the car handles steering, but you still control the brake, or spell checking, where the system flags an error but you decide the fix. The H metaphor, riding a horse. There is a really elegant metaphor for this called the H metaphor. H for horse. Shared control between a human and a machine is like riding a horse. You give the horse high level goals and it handles the low level details, but you both need some model for how the other behaves. This gives us loose rein versus tight rein control. On a familiar route, a horse know what to do, so you barely need to guide it. Loose rein, something is off. You drop into tight rein and steer directly. Researchers break this into four levels: strategic, tactical, operational, and execution. And automation designs should let users move fluidly between them. Three tasks allocation strategies. The big design question: which functions do you actually automate? There are three common strategies: maximum automation, automate everything you technically can. The risk is that humans get left with only the tasks that were too hard or expensive to automate. The leftovers, not that what they are good at. Second, assign each function to whoever is most capable, human or machine. Uh, this is based on some things called fits list, comparing what each is naturally good at. Third, economic efficiency. It's tempting but risky because it needs very accurate modeling of real world outcomes. So, all three strategies risk what's called the authority problem, losing the principle that a human shouldn't keep a final control. Levels of automation. Beyond just what gets automated, there is how much. Researchers use a 10-point scale. At level 10, the computer decides everything and acts completely. autonomously, ignoring the human. At level 7, it executes tasks automatically but keeps the human informed. At level 4, it suggests one alternative action and you decide to use it or not. At level 1, the computer offers no assistance at all. The human makes every decision. The point of this scale isn't to climb toward, it's to help designers deliberately choose the right level for a specific task based on the risk and the consequences if it fails. So, four types of automation. Automation can also be classified by type, mapped onto stages of human information processing, acquisition. Automation is about sensing and registering data like a radar sensor automatically locking onto a target. Analysis automation is inference over that data, predicting a trend or summarizing information. Decision automation actually selects among alternatives. Uh, think routine planning or a system supporting medical diagnosis and action. Automation executes the choice, anything from an automatic aircraft landing system to your OS, installing an update while you're idle. There is also fifth type adaptive automation, where the level shifts depend on the situation. User-centric evaluation criteria. So how do we know if automation is actually good? From the user side, there are four criteria. One, mental workload. Automation can lower it by organizing information or raise it if the system is hard to use. Situation awareness. Automation can quietly reduce how aware you are of what the system is actually doing. Complacency, over trusting an accurate seeming system means you stop monitoring it, which is dangerous the moment it's wrong. And skill degradation, the most important. The more the system does for you, the more your own manual and cognitive skills can fade over time. uh, System level evaluation criteria. There is also a system level view looking at the human and the automation together as one joint system. Automation reliability matters here. The true positive rate, meaning how well it catches real cases, and the false alarm rate, meaning how often it cries wolf. A high false alarm rate causes fatigue and honestly justified distract. Uh, the second creation is the cost of getting a decision wrong, weighted against workload, awareness, and skill risks. Put together, researchers use a six-step workflow, identify possible types and levels of automation, evaluate the human performance consequences, refine, then apply these reliability and cost checks to finalize the design. For applications of interactive AI, modern AI goes beyond simple automation. It's genuinely interactive. Four common patterns show up everywhere. Argumentation amplifies your ability, like autocorrect, letting you type faster and sloppier on a phone. Dialogue lets you interact through conversation, for example, Siri, Alexa, or think of any chatbot. Monitoring means the AI watches in the background and reacts at the right moment. A thermostat reading temperature or headset tracking your hand gestures. And recommendations are AI proposing options for you to choose from navigation routes, shopping suggestions, what to stream next. Most products you use daily combine at least two of these. The ironies of automation. Now, here's the part I find most important. In 1983, a researcher named Brainbridge identified what she called the ironies of automation, and they still apply directly to today's AI. The irony is the more you automate, the more critical the human becomes when it fails. First, the skilling. Rely on spell checking long enough, and your own spelling ability actually declines. Second, vigilance. Humans are just bad at staying alert when they are not actively engaged. So, exactly when you need to intervene, you're least ready to. Third, loss of agency. When the machine does most of the work, people feel like the automation did it, not me, which is quietly damages motivation. The real world stakes, the Boeing
Mhm.
737 MAX had an automated anti-stall system most pilots didn't even know existed. When faulty sensors triggered it, the pilots ended up fighting their own aircraft instead of working with it. Explainable AI and the big picture. Let me close with one more idea. Explainable AI. As AI systems make decisions with real consequences, insurance, medical diagnosis, users need to trust and understand why the system decides that. Uh, One nice tool here is the counterfactual explanation. Telling someone if you stopped smoking, your monthly fee would drop by 20 euros is far more usual than a raw probability score. But there is a real trade-off. Simpler explanations are easier to understand, but less accurate. That's the explainability accuracy trade-off. So zooming out, automation isn't really a question of how much can we automate. It's a task allocation problem, deciding what to hand over and making sure the human stays meaningfully in control so that when the system inevitably fails, someone is actually able to catch it. That's it from me. Thanks for listening. Happy to take any questions or dig deeper into any of the frameworks I covered.
Thank you, Yusif. I heard your speech. I liked your speech, and you exactly covered up all theories in the AI field, in automation field. Have you heard about the agentic AI? I think I don't see agentic AI in your cases.
Yeah, agentic, by meaning agentic AI, I think you mean AI agents that actually make automations in themselves. For example, today's world, we see a lot of AI agents that work with only voice control. For example, you prompt them to make an automation, and without you creating it, you just give the prompt and they create your automation however you want. Is that what you're talking about?
Yeah. It's good. I understand your the points of view. Everything is okay. And see, I have no question. I understand your cases. Thanks for speech.
Okay. Does anyone have any question? I'm open to answer any of your questions.
Oh,
Yeah,
yes, I
let's
have a
start.
question.
Oh, yes.
Okay, let's go.
First of all, hello everyone. Thank you for Yusuf for your presentation. And I have a question.
Okay, let's hear.
1 minute. İnternette biraz problem. Okay.
No problem.
My
Take your.
question, my question is, can you give real life example of automation?
Okay. As a real life automation, for example, when you go to WhatsApp and type your relatives or your friends, when you type in your keyboard, you say, "Hello, mom, I'm coming home. Do you need anything from the market?" Right? After you type it for 1 week continuously, the algorithm learns your patterns and continues to uh, complete your actions by time. The next day of that day, when you say, "Hello, mom, I'm in market," the AI in the keyboard automation understand your purpose and starts filling up those gaps, spaces with the automation and creates words that you used before. So without your permission or your observance, the automation in keyboard just created a workflow for you that you didn't even notice.
Oh, thank you very much.
Also, I have a question for Sir Yusuf. You mentioned the situation awareness in your presentation. I have a question. My question is, what's the situation awareness and how can automation affect it?
Yeah, that's a good question. I like it. The situation awareness is about being aware and observing your situation. What I mean by that is when you use a lot of automation in your life, which maybe seem good and relaxing, maybe it's less tiring for you because you do all of your works with automation, that makes your life easier. But when you turn and look back, you see that you have nothing to do and your situation gets deleted by the automation and your meaning gets uh, mm, deleted every day when you use more automation. And every time you use automations, you degrade your skills and simply you wipe down your skills. For example, let's say that you are driving car in a highway, right? Most of the cars today have automation to cruise control, and when you don't even touch the steering wheel, the car controls itself. As long as you do this, your steering skills gets faded because the automation handles it. So that's what you're talking about, situation awareness, being aware of the situation and not letting AI and automation to completely control your everyday life. So you become more controlling and observant over your life.
Thanks for answer question.
Okay. I'm happy to answer your questions. If you are done with your questions, I was very happy to show you my slide and talk about automation and AI. It was a fun topic. Good to see you, everyone. If you don't have any questions, and Ertuğrul teacher, if you don't have any other questions, I want to end that meeting.
Digər iştirakçıların əgər sualı yoxdursa, bugünlük çıxışımızı və mitinqimizi sonlandıraq. Sonda bu mitinqə qoşulan hər kəsə çox təşəkkür etmək istəyirəm. Bu gün mitinqimizi biraz ingilis dilində eləməyə çalışdıq. Yəni biraz necə deyirlər, brainstorming eləməyə çalışdıq ingilis dilində. Amma bundan sonrakı mitinqlərimizdə həm ingilis dili, həm Azərbaycan dili, əgər iştirakçıların və mitinqi dinləyənlərin ingilis dilində hər hansı bir yerdə anlamadığı ifadə varsa, biz onu Azərbaycan dili məmnuniyyətlə cavablamağa hazırıq. Bugünkü necə deyirlər, diqqətinizə görə çox təşəkkür edirik və mitinqimizi burada sonlandırmaq istəyirik. Digər görüşlərdə də davam edəcəyik və digər görüşlərdə sizlə görüşməklə çox böyük məmnuniyyət duyarıq. Çox sağ olun dinlədiyiniz üçün.
Oldu, sağ olun.